Regression Example 2, a continuation of the Zagat Restaurant Ratings example. Let's review the scenario one more time. Zagat publishes restaurant ratings for various locations. Data has been collected for overall rating and price per person at 50 restaurants in New York City, 50 restaurants on Long Island. We have already developed a regression model to predict price per person based on overall rating and whether the restaurant is in New York City or on Long Island. Again, you may assume linear regression is an adequate model. Quick review, we're trying to predict price, so that is our Y variable, based on X1 rating and X2 location, which is a dummy variable, New York City or Long Island. Let's look at the questions we're going to answer this time. Two questions. Is there an overall significant relationship between price and the two variables together, X1 rating or X2 location at the 0.05 level of significance? And if there is overall significance, we will then need to go to question 2 to determine whether each independent variable makes a contribution to the model. Here's the Excel model, which has already been run in example 1. So let me give you a moment to look at it and see if you can tell where we're going to be pulling the information we need to answer these two questions. Again, the first question is overall significance of the model. And as you may recall, it is an overall F-test. So here is where we will be looking. I'm going to do a test for overall significance, the F-test, and I'm actually going to do it from the shortcut perspective. So let me give you a thorough null and alternative hypotheses. Again, this is for overall significance. Question 1. Our null is that slope of x1 and slope of x2 are both equal to 0, which means there is no evidence of a relationship between Y price and overall rating x1 or location X2. If that is the case, we'll toss these and investigate other variables. Our alternative is that at least one of these slopes does not equal 0. In other words, there is evidence of a relationship. Between Y price and at least one of the x's, or at least one of the independent variables. X1 rating, X2 location. If we reject the null then, at this point we will have to investigate each independent variable separately. In other words, keep going. Investigate each x separately with a t-test. Again, I'm going to do this from a shortcut perspective, so if we go back to Excel We've already taken a quick look, but let's look again. F, the overall significance level, F, is a 70.23. That is a big F. It is way beyond what we would expect our rule of thumb to be for a reject region of around 5. Anything more than about 5, big F, we will reject. So let's write that in a shortcut fashion. Big F equals 70, greater than our rule of thumb of about 5. Therefore, reject, which means, of course, keep going. But let's write out a thorough managerial conclusion. There is evidence of a relationship between Y price and at least one of the independent variables. X1 rating, X2 location. We will now have to investigate each X separately with a t-test. That answered our question 1. The model does have overall significance. So let's go straight into question 2, which was to investigate the significance of the individual variables. Back to Excel one more time. Let me get a clean sheet here, but back to Excel. This time we're going to be doing the individual t-test. So we need to look at the t-statistic associated with each slope. In other words, here are 2 independent variables. Here are the 2 test statistics we will look at separately. Let's first of all look at the significance of the rating, X1. Again, I'm going to do this from a shortcut perspective. This is question 2, significance of individual variables. First, we'll look at X1 rating. The null is that the slope of X1 equals 0. If that's true, there is no evidence of a relationship between Y price and X1 rating. If that slope is 0 and there's no relationship, our action will be to toss it. You would exclude rating from the regression. Our alternative is that the slope does not equal 0 for X1. In other words, there is evidence of a relationship. Between Y price and X1 rating. We'll keep it. It's contributing to the regression. In other words, we will include it in the regression model. From a shortcut perspective, we'll now look at the t-value associated with the slope of X1 in Excel. And you will see from your screen it is 10.7. That means that it is 10.7 standard deviation from the center. It is at the extreme end of a tail, much greater than the rule of thumb of 2.5 that we would expect to see separating our reject and our do not reject regions. So that is a big T. Much greater than our rule of thumb of 2.5, absolute value of 2.5 if this had been a negative T. Therefore, we reject the null. Let's get a good managerial statement in action then of what this means to us. There is evidence of a relationship between Y price and X1 rating. Our action will be keep X1 rating in the regression model. We have to do the same thing now for the slope that corresponds to X2 location. I am not going to take the time to write that one out because you would do it in the very same manner, but let's look at the value in Excel. The T corresponding to the slope of X2 location, negative 6.29. In other words, it is over 6 standard deviations from the center of that T distribution, very definitely in the reject region. So again, we will call that a big T. Now, of course, it's a big absolute value of T, meaning reject the null, meaning keep X2 as well. So in this example, we have found, first of all, overall significance. We had a big F of 70, which told us keep going. We'll now need to investigate each X separately. We looked at the slope of X1. We had a big T of 10.7, which meant keep X1. Then we looked at X2. We had a big absolute value of T of X2 of minus 6.3, meaning keep that as well. So for this multiple regression model, both location and rating do contribute to our understanding of predicting the price for restaurants based on rating and location, New York City versus Long Island.